यस मैम। हाँ मैं हॉस्टल से कर रहा हूँ। हाँ मैम ऋतिक आ जाएगा सर चलिए। वैसे है मतलब रेडी हो गया। हो गया हाँ उधर यही ऊपर ही
अरे कोई बात नहीं, रहने दो, हेड सब वगैरह करो ना, हम लोग है ना, काफी है। कोई जरूरत नहीं, टाइम लॉस हो रहा है। हम लोग काफी हो गया
थोड़ा सा
इकबाल भाई गुड मॉर्निंग।
Good morning.
Hello, hello, hello. Hello.
Good morning, everyone. A warm and cheerful welcome to all of you. It's such a pleasure to see such an enthusiastic gathering today for day 3 for enlightening us journey in the world of remote sensing and GIS.
We are so thrilled to have you all here in Hall A26, ready for another day filled with learning, innovation, and engaging discussions. A big thank you to each one of you for being here bright and early, eager to dive into today's session.
Before we start, let's take a moment to appreciate the thought and effort that has gone into organizing this event. A round of applause for the incredible team that made it possible.
Let's give a big round of applause. Now, we also want to thank our esteemed resource person who brings with them a wealth of knowledge and experience. Let's make sure to give them our utmost attention throughout the day.
So, without further ado, let's take a look at what we have lined up today.
Our first session will focus on the application of RS and GIS in soil mapping. This is a crucial topic that highlights how technology can transform the way we study and manage soil resources.
This session will be led by our highly respected resource person, Dr. B.D. Yadav sir. He has a wide academic background, includes BSc in Civil Engineering from BIT Sindri, MTech in Engineering Geology from IIT ISM Dhanbad, and PhD in Geotechnical Engineering from the same institute. He has got the Best Research Paper Award presented in the International Conference on Water, Environmental, Energy and Society organized by uh, AICT Bhopal University, India.
Now, I would like to brief about the topic remote sensing and geographic information systems are powerful tools for soil mapping. RS provides special data for satellite imagery, enabling large-scale analysis of soil characteristics. GIS integrates these datasets with topography, climate, and land use information to create detailed soil maps. These technologies enhance soil classification, fertility assessment, and land use planning. Offensive, cost-effective, and accurate solutions for sustainable land management.
Without further ado, let's get ready for today's session. Please join me in extending a warm round of applause as we invite Dr. B.D. Yadav sir to share his valuable insights and expertise with us. Thank you so much.
Yes. हाँ सर.
कहाँ से बढ़ेगा?
ये माइक भी यूज ये पॉइंटर
ये पॉइंटर है.
और सर इसी यही इससे आगे होगा सर और इससे पीछे होगा सर इधर वाले से आगे होगा
दाहिने तरफ आगे.
हाँ
ये आगे और
इधर से पीछे होगा
इधर से पीछे.
बीच वाला से पॉइंटर
बीच वाला से पॉइंटर. ठीक है. Very good morning to one and all. Thank you, organizer, to give me a chance to present here. किसी का मोबाइल बज रहा है. To present a lecture on application of GIS and remote sensing and soil mapping. In fact, when Komal gave me offer, then only on upper part I have said yes. But when I go deeper and deeper, this topic is very crucial, very complicated and wide range of application. Here I have tried to explain through case studies that how remote sensing is useful in our day-to-day life in geotechnical engineering. I request delegates especially our newcomers, MTech students who have been gathered here to learn and try to understand the themes. I am always here and I am your single permanent teacher in geotechnical engineering and will explain further and further. I have a bunch of research papers in this area I have collected just recently. You can cope up with me. Now, this is topic of soil mapping. Just as name is saying that a map should be prepared. How a map should be prepared? Just I have seen contour maps and other maps in surveying and engineering, but how a map should be prepared for geotechnical properties. We can prepare soil maps for each and every geotechnical properties, either that is plasticity, that is bearing capacity, that is shear strength, that is compressibility, consolidation, compaction, and every n values, है ना? Then, so soil mapping. In case of you have learned in contour map that every points cannot be plotted. So we choose certain points and then interpolation should be done for other points. Here also I have tried to learn a process which can easy for preparing soil map. Now, this is my outline of the presentation. Tell me, what is GIS? Some scientists told that a fundamental and universally applicable set of value-added tools for capturing, transforming, managing, analyzing, presenting information that are geographically referred. You can understand each and every point, capturing, transforming, managing, analyzing, everything is there. Now come to usage of GIS in geotechnical practice. Data integration, simple. I have some knowledge, and we can integrate other modern knowledge. That is data integration, data visualization, analysis. If we collected data, then we should analyze the data, planning and summarizing site activity, and then presenting some other forms. What is remote? As the name said, remote. Remote means the location where we can not reach. So collection of data about Earth's surface from a distance using multi-spectral, hyperspectral, satellite or aerial imagery. Remote sensing works through sensors, satellites capture electromagnetic radiation reflected from Earth's surface. Data is determined soil properties. Now some reflected waves are captured by our Earth's surface, and that is important for gaining knowledge about geotechnical properties. Remote sensing techniques. Remote sensing uses these optical sensors, microwave sensor, hyperspectral sensor, and thermal sensors. This is the sequence of operation of GIS in geotechnical engineering. You can see 1, 2, 3, 4, 5, 6, 7, 8. Scope and objective of the project, data acquisition, data preparation, data integration, data exploration analysis, geotechnical modeling. Just we learn geotechnical modeling here through some case studies and risk assessment, decision making, visualizing and reporting. 4 M's of GIS. Geographical information system have 4 M's. First M is measurement, monitoring, modeling, and one is visualization is not so important part, and measurement mapping of what. This is some examples of here you have given only six, but others are also. LCULU means land cover, land use. Hydrological, geotechnical, geological, topographical, geometry, other geotechnical properties. You can understand. This is a case study. I have present initially, but this is a case study. GIS for geotechnical problem in urban areas. In modern city or thinly populated city like Kolkata, like Bangalore, where day by day population are increasing. Increasing due to the weight of on the upper surfaces. There is problem of subsidence. Just like in coal bearing area. Here in Jharia coal field we can see subsidence problem. So in urban areas problem of geological, geotechnical, geochemical. Just like what is liquefaction? I have said just now that each and every geotechnical student should know liquefaction. In simple terms, as Morse Coulomb theory says, for saturated soil condition and very fine soils in sandy, where cohesion is zero. Tau is equal to sigma minus u 10 phi. Under the dynamic load condition, pore pressure, excess pressure diminishes the value of sigma minus u. When sigma minus u becomes zero, then it has no shear strength and it flows like a liquid. And this terminology is called liquefaction. And urban area have liquefaction susceptibility potential underground. Lithology of soil potential, topography, geomorphology of the area, consolidation and compressibility problem. Just you see in Kolkata we are discharging liquid from underground water, and it creates vacuum just like Jharia coal fields. We take out coals and vacuum is created. So for upper strata pressure, it breaks down and goes like just subsidence. So subsidence like problem also occurring in Kolkata, Bangalore, or in future it has some problem. You can see just like GIS technology has prepared such maps. Suitability to construction, considering slope layer, consolidation and compressibility potential in combined condition of geological, and hydrological. This color is suitable for construction, and remaining other color is not suitable. So GIS tells that in urban areas which area is suitable for construction and which area is not suitable for construction. This is one application in urban areas. Now come to soil mapping. Soil mapping. Classifying and especially representing soil properties and their types of soil mapping. I have written only 8 or 9 or 10. But there are mapping available for all properties of soils. Mapping of soil properties, physical properties, chemical properties, hydrological properties, evolution of soil mapping. This is traditional method and modern approach also. Now emerging technologies. You can say software used in GIS for a geotechnical engineer. You can read this ARSGIS. We are using more QGIS, GIS, Spring 4, Surfer 11, SGMS. These all are software. Others are also. Just I have mentioned only these. Now after capturing the data, we have problem of geotechnical soil models. You can see for preparing soil models. First step is collection of geotechnical investigation report. We go to the field and collect some previous data records. Then extraction of soil parameters. Just this is for n values soil tapped 100 shear strength. So this is a case for preparing geotechnical soil models for n values soil tapped 100 shear strength coordinates. Now statistical analysis of n values. Now prepare suitable interpolation techniques. Now just after this we see what are the different interpolation techniques and I explain only one which I have used further. Now for this types of soil type GIS interpolation techniques. These are right interpolation techniques. IDW, global inverse distance technique of interpolation. We collect data from some places and interpolate for others. It cannot be possible to take each and every data of each and every place and test it. It is infinite work. So only some portions are sampled and some are unsampled, which can be solved by interpolation. This is inverse distance techniques for interpolation. L is the split length. LIK means from sampled spot unsampled distance between split length sampled spot to unsampled spot. Delta X coordinate along x-axis and y-axis and ZK parameter values for unsampled spot. And this is the our formula. Now and Vaughan 23 given the correlation coefficient which are used in GIS software. And this is formulas for CND numbers for concordant means and discordant means pairs. What it means? Concordance means both x and y are either increasing or decreasing. X is greater than y. X is xi is greater than xb. x is greater than xb, y is greater than yb, or x is less than xb, and y is less than yb, this is coordinate pairs. And if x is greater than xb and y is less than yb, one is increasing, another is decreasing. This is called coordinate pairs. In the above formula, Hermann-Voggen, this correlation coefficient limits from minus 1 plus 1 plus signifies increasing correlation, and negative gives decreasing correlation plus 1 very strong correlation. So minimum value is minus 1 and maximum value is plus 1. This is all about agriculture point of view. Case study 1. Soil salinity mapping. This is not full for geotechnical engineers, but I have presented here. In this all the red lines are greatest saline and green. Case study soil erosion risk assessment, है ना? Methods used combined vegetation cover, slope and rainfall data. Soil erosion risk assessment. This is the map prepared by software and all legends show this legend low risk, green color low risk, medium risk, high risk. This zone is highest soil erosion. Case study 3. In this flow chart you also can see that this is our Russell formula, in which C factor, K factor, R factor, LS factor, P factor are used. LS factor, slope length and steepness, and these are steps. This is CA Markov modeling for land cover land use. You can revise universal soil loss equation, है ना? Given by Renaud et al. 1997 A equal to R multiplied by K, and A means computed soil loss for unit area, R rainfall runoff factor, K soil erodibility factor, LS combined slope and stiffness factor, C is equal to cover management factor, P is support practice factor, and this is for R. This is for R, log R is 1.74, PI monthly rainfall, P annual rainfall. In this formula you can use. So R is determined. Now K factor. This is formula for K factor, in which OM is organic matter, S is soil structure, P is soil permeability class, M is product for primary particle size fraction. This is combined L and S factor, है ना? L and S factor. Here in this sign B slope in degree, AS accumulated flow in meter cube per second, CPK factors have been produced in tabular form also. Now see, this is land use land cover. Here you can see that if we have data for 2010, 2017, then